So it's kind of live still here in Spain.
Yay! So welcome to the April. This week off is going to, or this week early is going to get me too. Welcome to the April Northwest C++ user group meeting. We are 1 week early this month, which all of you guys got right. Next month, we go back to our regular third week of the month, but we will stay at 6:30. So our new meeting time is 6:30 to 8. Basically, we're in the reactor room, so they're kind of aligning all of the different sessions to happen at the same time, so people aren't, staying late to keep the room open for us and stuff like that. Other than that, I don't have any particular announcements. Oh, wait a minute. I do have one. So I can't remember if it's September or October, we're going to be doing lightning rounds. So if anybody wants to do a little mini talk, be prepared for that. Probably, I think it's August or September, we're going to do a pizza get together. So I'm going to try to book we won't do that here. We'll do that at a park, and we'll book one of the park shelter or the picnic shelters. So keep your eyes open for that. Chris, did you have anything you want to announce for conferences?
None of my conferences have any, any announcements, but Meeting C++ in Berlin just opened their call for submissions today. So if anybody wants to go to Berlin, that's a place to be.
It's a very nice conference indeed.
Okay, with that, I'm going to turn it over to Diego from Conan. So Conan Package Manager 2, is that correct?
Yeah.
Did that off the top of my head.
That's okay. Correct. That's correct. Hey, Robert, how are you?
Good.
Okay, so hi everyone. Let me present this. Yeah, so today I'm going to present about Conan, Modern C++ Package Manager with Conan 2 actually, and I'm going to present modern practices that have been around for a while, but I'm also going to present some new features that haven't been announced yet. So I hope you like it. My name is Diego, in case you don't know me, and I'm one of the co-founders of Conan. And I wanted to start this talk. I did, Chris, if you recall, in Meeting C++, I did a similar talk. It started the same, highlighting the pain, because this is the situation. This was the ISO C++ survey last year. And the top 4 pains was basically managing libraries, build times, CI, and managing CMake. And at the same time, when they were responding, hey, how do you manage your C++ libraries? Most of the people, they were saying, hey, I'm just bringing the source code and doing a copy, or basically compiling the libraries myself, manually, kind of. And I wanted to show that this is not the case anymore in 2024. And we have good solutions. We have VC Package, we have Conan, that can provide much better solutions than doing that manually. And this is what I'm going to so by the way, in today's talk, I'm going to do a lot of demos. I love doing demos. I try to make them in all my presentations. Also, if you have any questions at any time, I think we are just few people, so you can stop me anytime, and you can ask anything. Okay, so here I built a small example, which I'm going to use because it's trendy. I'm going to use artificial intelligence. So I'm going to show you the code. This would be an application that is using the TensorFlow Lite library and also OpenCV for image processing. The TensorFlow library for artificial intelligence post recognition, and the OpenCV for processing the image. So this is the source code. It's nothing really critical here. The first thing I wanted to show is the CMake list. The CMake list is this one, and the thing that you should pay attention is that this CMake list doesn't contain anything at all about Conan. It's just pure standard CMake list. The only place that I need to introduce something new is this is a Conan file. It's a file where I'm declaring my dependencies. In this case, I declare that I'm depending on TensorFlow here, this specific version, and also I'm depending on OpenCV, this specific version. And as Conan also integrates with every build system, in this case, I'm going to use CMake. I could be using Visual Studio, native MS Build solutions as well, or I could be using Meson, and Conan can integrate as well in the same way. But in this example, I'm going to use CMake. So with these files, then the way to install dependencies would be something like this. Conan install, it will be getting the Conan file, it will be getting these two dependencies and all the transitive dependencies, because TensorFlow and OpenCV, they have transitive dependencies. So Conan is fetching all of them. The first thing that we are seeing here right now is that Conan is also able to fail fast. In this case, there is one of the libraries, TensorFlow, that requires C++17, but my current standard is 14. So before driving me into compiler errors because the C++ standard is not enough, it's saying, hey, there is one of the packages that requires C++17. That's fine then, because I can specify, okay, don't worry, because I'm going to use in my compiler cppstd, I'm going to use C++17. And then Conan will manage now to resolve the dependency graph, and now it's downloading pre-compiled binaries for my configurations. Because in this case, I'm using Visual Studio release configuration with the latest Visual Studio compiler, and Conan managed to download pre-compiled binaries from the server for me. And as you can see, it took just a few seconds to fetch all the dependencies. And from now on, this is a standard CMake flow. I can use preset, Conan default, and it will be generating my, in this case, a Visual Studio solution. For my dependencies, I could open my IDE and build from the IDE, but I'm going to build also from the command line because it's just more convenient for the demos, and I will be building the release application, and if everything works well, then I will have my application built and hopefully running. And yep, this is it. So we can see the video processing of this person dancing here, and the post detection is working fine. So the amazing thing is that we managed to have an application running that depends on around 50 different libraries, C++ libraries, in a machine that it didn't have the libraries at all in just a few seconds. So this is the kind of modern experience that you can get with modern package managers as today. So my message here is that there's no need to keep compiling manually your libraries into your projects or anything like that.
I have a question.
Oh yeah, go ahead.
So what if you need libraries that have been compiled with a specific compiler flag? So maybe for safety, you want to compile everything with one certain compiler flag, but these have all been pre-compiled and then downloaded.
Yeah, so there are ways to, for example, to inject compiler flags into dependencies. Just, hey, I want to install, for example, with tools, build CX flags. This will be something like this. That I don't know. Let's say that actually the command line is something like I don't know. And then you can inject these compiler flags into the dependencies, and it will compile with those dependencies. You can also force the build. You can force the build from source from your dependencies if you want as well. So something like this will make the rebuild of your dependencies and injecting your compiler flags as well.
Great, thank you.
Yeah. Any other question?
Yeah, I have another, not such a specific question, a more general question. This sounds to me awfully like Python pip. I have been using the pip package manager.
Yeah.
You're aware of Python's pip package manager? No.
Sorry, your voice was breaking a little bit. What was?
Yeah, you might need to.
Are you
Yeah, we got mics here, so you might need to come close.
Are you aware of Python's pip package manager?
Oh yeah, of course. Conan itself is written in Python, so we use pip a lot.
You use pip a lot. This looks awfully like pip to me. But yeah, here's my more general question. My issue. Pip was very easy to use several years ago when there were not too many incompatible versions of Python packages, etc. These days, it's a nightmare. I can never get anything to work with pip. I say Python pip install something incompatible. Go and check the error log, and you have to fix it manually. Do you run into issues like that? I suspect you will have issues like that. And how do you deal with them? Incompatible packages.
Exactly. So it's possible to have incompatible packages, and specifically with C++, the binary management is complicated as well. But it's also true that the main problem with Python packaging is that is a flat installation of packages. So basically, you need virtual environments to isolate your dependencies. While the way that Conan manages dependencies, it can install as many versions of the same dependency and as many different binary variants of the same dependency in the cache without conflicting. So you can have multiple projects, and one project can be using one version of the library in a static mode, for example, and another different project can be at the same time, can be using a different version of the library insert dynamic linking, right? So this kind of conflict doesn't happen with Conan because Conan gives like a different folder for every different variant of the dependency. So in this way, it avoids the conflicts.
Python's solution to that problem was to Canonical to come up with different environments. For you, when you need Python 2.7, you create a separate environment for it, and you need a specific package, and that leads to a lot of duplication, a lot of disk space, and they have a very heavyweight constraint solver. I don't know if you've seen the Python pip constraint solvers trying to solve its constraints for a compatible set of packages. It takes a while sometimes, and sometimes it fails. Do you have a similar constraint solver? Probably because it's based on pip.
So it's true that in the Python ecosystem, they're having like multiple solutions, like Poetry and like recently Rai and the UV that is like a modern, and they are trying also to improve over the experience. And one of the problems is that of finding the joint compatibility of solutions.
Yeah, finding a compatible set of things that you can get something to run. These days, it is becoming increasingly difficult.
Yeah, it is. But it's also the problem, the space of the problem in Python is slightly different because in Python, in Python pip and PyPy, you have, I don't know, like 100,000 packages, something like that. And in Conan Center and BC package, we are in around the number of 2,000 different libraries.
That should make it.
And the amount of library that you also need in a C++ project, we have users, and the amount of specifically third-party libraries that will be the ones that can be configured more. They will be using, I don't know, between 50 and 100 different libraries in a project. Okay, because also these libraries, these packages, some of them tend to be very big.
How does this solve it?
If you're using Qt,
incompatible packages, etc.
You are bringing with Qt, you are bringing the equivalent of, I don't know, 1,000 Python packages. So Qt is giving you like a whole framework to work with. So it's not typical for C++ projects to have as many dependencies as other kind of projects like
your packages in Python.
Yeah, exactly. That's more or less the difference. So I don't know if package managers like DC Package and Conan, they keep getting traction, we might end at some point that we have many thousands of C++ packages with many versions, and the problems of conflicts seems more relevant. But as today, I wouldn't say this is our major problem in the package management in C++ ecosystem. We have more like We need more people to onboard package managers, and we need to standardize. I'm going to talk about standardization at the end of the talk as well. So we also need to standardize interfaces and things like that. So I think our problems are slightly different at this stage than other languages like Python.
And if I may make another comment, it seems you have a single target x86 processors, AMD 64 something, but in the news these days, Google is developing its own GPU, and AMD has its own version, and Intel is coming up with their own GPUs, and then I suspect you will have many hundreds of thousands. Not there yet, I suspect.
Yeah, but I'm not sure what is the question there.
Multi-targeting, multi-architecture, multi-processor targeting. Do you target just x86?
No.
ARM.
In the Conan default settings, we have defined at least like, I don't know, 30 or 40 different architectures, and you can extend those architectures even more. Yeah. So you can target any. Actually, we have tons of users in the embedded space that they are using very weird architectures and things like that. So it's not that we are targeting one architecture. You can target. Conan is the package management framework. It's not opinionated that much about architectures.
No, but the point I was trying to make was that each new architecture adds. If you have 10,000 packages, then one new architecture, then you have 10,000 more.
But that's a different problem. I think a central repository will never build binaries for all the different architectures and variants. That would still be a responsibility of the users building their own binaries and caching their own binaries in their own servers, because there is no way that a C++ central repository can build the binaries for the whole world. That's impossible. That won't happen. So Conan Center, in this case, for example, is building a bunch. It was building like around 100 different binaries for Windows, Linux, and Mac, just to guarantee that things are working. But the aim is not to provide the binaries for the whole world. That's impossible. The aim is to have a framework that can create packages for all architectures, and users can build their own binaries for their own architectures and cache their own binaries in their own servers.
Do you have a default repository? Do you maintain your own Conan something?
Yeah. I will be talking about that later. Okay, yeah. So maybe we can continue a little bit. You will also learn a little bit about Conan Center and other stuff here, and we can also talk about that. Okay, so I wanted to talk a little bit about the demo that I ran, how it worked. So I was defining in my Conan file, I was defining my dependencies, and I also defined the generators. I defined the CMake deps generator and the CMake toolchain generators. These generators are creating for me CMake files that I'm using while I'm building the application. For example, the CMake deps generator, it generates the typical config.cmake files for finding and using the dependencies. So for a dependency like setlib, Conan is able to generate a file that contains the include paths, the library names, everything that can define. When you use the find package, it will contain all the information to link the dependencies correctly. And also on the other hand, the CMake toolchain is providing the user presets, the CMake presets, and also the toolchain to align the settings. When I was typing compiler C++ std 17, then that 17 is in the Conan toolchain CMake to guarantee that my configuration is aligned, my build configuration is aligned with the dependencies configuration, because otherwise we saw that TensorFlow, in this case, it requires C++ 17, so my current CPP std needs to match the dependencies requirements of the CPP std. And then the CMake toolchain is also able to generate the presets. Presets is a very convenient file. It's a JSON file that basically contains a bunch of things that most of them you can type them in the command line, but it makes it very inconvenient. But you can put them in a JSON file, and then you just pass the name of the preset, and then it makes the user experience, it makes it very good. So Conan, the CMake toolchain generator, is able to generate a presets file that contain the generator that we are going to use, like Visual Studio 2022, and the path to the toolchain file as well, and the configuration release. Whatever it needs is going to be defined there. So just when you use just the CMake preset, everything will be there, and the build will be correct. Okay, one of the things that many users ask, especially the maintainers or the build engineers, that they have many developers, say, oh, okay, but can I have a CMake only flow where my developers only type CMake? They don't need to type Conan install at all. They just type CMake, and it will manage automatically the installation of dependencies for them. So let me show you. I'm going to clean my project, so the build folder has been wiped. And now what I'm going to use, I'm going directly to start with CMake. Okay, CMake preset default. So I'm not going to call Conan install. I'm just going to type CMake preset. And we can see here that the CMake preset is defining like a file. And this file is going to automatically manage the installation of the Conan dependencies, as we are seeing here. So from now, we could open the IDE as well and build from the IDE, but in the same way that I did before, I'm going to build from the command line. And I should be able to build my application, the XML application that I built before, so it should work again. But in this case, the application, I built it, I installed the dependencies, and I built it just by typing CMake commands.
We've got a question in the room.
Okay.
So,
question? Yeah.
Yeah, could you go back to the previous slide? Did I understand correctly that when you run Conan install, if you don't have a CMake presets.json, then it will generate the file on the right for you, or what? Did I misunderstand something?
Yeah, this is a little bit abstract. So actually, it will generate something like this. It will generate a CMake presets that is inside a temporary build folder, which is the generators folder. Okay, so it doesn't conflict at all with any CMake presets that you may have in your project. And then if it detects that you don't have a CMake user presets, then it will generate automatically a CMake user presets for you that includes the CMake presets. So the idea is that Conan will not be overwriting a CMake preset that you have, and it allows you also to have your own CMake presets if you want. So the main information there is in a file that is inside a temporary Conan folder.
Okay, so if I have a CMake user presets already, I need to modify it to have the include to the generator's temporary location.
Yeah, exactly. So if you have your own presets and you want to use the Conan information, then you need to include the Conan generated file. That's correct.
Thank you.
Okay, so how was this implemented? So this is leveraging a feature that is called the CMake dependency providers. A dependency provider is a CMake file that you can inject. You typically inject it with the CMake project top level includes. You pass the file name, and then this file allows you to define a hook that intercepts the finding package calls. So whenever a user CMake list contains a find package, instead of calling the CMake built-in find package, is going to call the implementation that you provide in your provider. So this is what the Conan provider is implementing. A little bit simplified, but this is more or less the idea. First, it will check that the Conan install has been already run or not, because in a CMake list you can have multiple find packages, right? And you don't need to Conan install all the time. You install Conan install once, and it will install all the dependencies. So you don't want to be running Conan install again and again every time that a find package is found. So we have a check for that. Then we also have a check that Conan is installed, just for convenience and a little bit of user experience. This is important. This is the the mapping of the current CMake configuration to a Conan profile. Why? Because when you are installing dependencies, those dependencies, the settings, the configuration of those dependencies should be aligned with your current one. And these dependencies, they can be built with other build systems. So from the dependencies that we have used, many of them, they are not using CMake at all. They are using the Meson build system or they are using auto tools. So this profile, this Conan profile, is the abstraction that allows to communicate the configuration to the different build systems. In this case, we are getting the configuration from CMake, translating to a Conan profile that is passed to the dependencies, and the dependencies will transform, the Meson will transform to Meson files and so on to make it work. Then we will be finally calling the actual Conan install, the equivalent that if I type Conan install on the command line. And finally, we will be calling the built-in find package. If you realize there is a bypass provider here, so it doesn't enter an infinite loop, and this will be the call, the actual call to the built-in find package. Okay, so now we have two different developer flows, right? So first, the developer that we tend to call the canonical one is the Conan install, and then you are using the CMake with the Conan generated presets. And also we have what we call the CMake Conan integration, that is you just call CMake, and with the Conan provider for CMake, CMake is able to automatically call Conan install for you and install the dependencies for you. And a very common question that we get is, hey, okay, which one is the preferred one? The first one or the second one? And our response is typically the first one. We prefer Conan install being explicit and then calling CMake. And there are many reasons for this. But one of them is that Conan is a tool, right? It's a powerful tool. It has many options and everything. So trying to hide the tool to the developers is sometimes not worth it. It's better that the developers get to learn the tool. And I will show you what. For example, when we are installing dependencies, there are things that can go wrong. There can be conflicts in the dependencies. There can be missing binaries. There can happen many things. And Conan has the tools. For example, we have the Conan graph info. We can type this thing. We can select the format HTML, and we can dump this to an HTML file. Okay, and we could open the graph HTML file, and we will see that we have this. We have our Conan file, and our Conan file has two dependencies, right? One of them is the TensorFlow Lite. The TensorFlow Lite in this case is complaining here, is saying, hey, this is invalid because the CPP STD is not enough, and this is the reason it's marked in red, right? We will see that Conan file also depends on OpenCV on this other hand. And we can do things like, hey, open, and we can mark all the packages like, hey, we can find the packages because there are users with big dependency graphs, and this can be very useful. And if we want to know, for example, hey, what are the package types? We can see that, hey, CMake is an application. We have static libraries here. We might have here, we have a heteronomy library, and we can also understand the dependencies. We can check the dependencies and we can see the traits of the dependency. Hey, the relationship between OpenCV and this library contains these traits as well. And we have a bunch of here, what we call tool requires or build requires, which are tools. We can also hide them, for example. So this is a powerful tool that allows you to learn about your dependencies and troubleshoot problems and everything. So it's very good if you know a little bit about Conan and you are not afraid of calling the Conan tool like Conan install. And because this is just also the tip of the iceberg. There are many Conan commands there. For example, Conan graph outdated that can give you the list of, hey, there are new versions in the server that you might update your dependencies to these new versions. If you have missing binaries because there is no binary for your current configuration, it will explain you why. What is the difference? Is it the compiler version or is it the dependencies version that is not matching? And it will tell you the reason why your binaries are missing. It allows you to manage your remotes. it allows you to create a log file so you can reproduce your dependencies in the future. This cannot be done with CMake, with the CMake wrapper. CMake wrapper is good for calling Conan install, but no more. But all of these tools should be in the toolbelt of a developer, in the same way that a developer should understand Git. They should understand also their package managers.
I have a question, okay. I guess, for that last preferred. Is it possible to use both?
To use both what?
Yeah. So your dependency provider, is it able to detect if install is already run if you run it with the CLI command? Or are they kind of not compatible with each other?
That's a good question. So they're compatible. They are partially compatible. You might be running from the command line and also CMake, but yeah. I think because they are using mostly the same infrastructure and the same information, so they are mostly compatible. Yeah. Okay.
I mean, the reason I ask is I often have developers that want to use the CLI tool, but then we have subject matter experts that just want to open their IDE and it just should work, and they don't want to learn the tool.
That makes sense. The problem that we have seen with many users that adopting the CMake Conan wrapper is that it looks good initially. Okay, yeah, my developers are happy because they don't need to go to the terminal and type Conan install. But the problem that they learn is, okay, when something is wrong, when a dependency is missing or something, they just say, okay, the build is broken, and they will go and complain to the build manager or to the developer instead of trying to troubleshoot. When you try to hide too much from the developers, then they will hey, this is a build problem, and I'm not going to troubleshoot you. So it's kind of a double-edged sword, trying to hide too much. So yeah, it's a trade-off. I understand. I mean, there are many CMake Conan happy users, so it has a value. So we are not saying that is the only solution will be Conan install plus CMake. CMake has it. For example, we use it. It's very, very popular for IDEs. I mean, complete for CLion, which is based in CMake. The CLion plugin, the CLion integration is using the CMake Conan integration. So developers that are using CLion for deployment C++, they will automatically be calling Conan install for the dependencies from the IDE because they are using the CMake Conan integration. Does this make sense?
Yes, thank you.
Okay, good. Okay, so we have been using, and we saw in the dependency graph, we saw like 50 packages there. Who is providing these packages? So these packages come from Conan Center. Conan Center is a central repository that we maintain. It contains around 1,500 recipes. Each recipe will contain a few versions, and every version will contain a bunch of different binaries for the different platforms, and is very widely used nowadays. I have to say that we have this Conan Center thanks for the community. So for a reference, this is the number of pull requests, the ones in red that we got in Conan Center. It's missing the numbers of 2023. In 2023, we reached 6,000 pull requests in 2023 alone. Okay, that's a ton of contribution to the community, which is honestly, this is one of the things that made me really happy. The community there is amazing. So the packages that I've been using today for the demo, we didn't create them. It was the community contributing them. And of course, we also have private servers like Artifactory. Okay, actually, for this demo, I was using a local server because I didn't want to use the network that much while video conferencing. So I'm running let me check. So I'm running here my own server. So what I did here is I did a copy of the packages from Conan Center and I uploaded them to my own server here. So when I'm using for the demos and everything, instead of fetching from Conan Center, I'm fetching the packages from my own server.
Question on that.
Yeah.
Oh, maybe this is what you're about to show, but you said you copied the packages. Are the recipes also copied, or are you using the recipes from Conan Center directly?
No, both. Actually, package binaries cannot live without the recipe. So when you copy, when we say we copy the packages from Conan Center to my private server, the recipe also goes with the package. The package cannot be alone. It goes with always with the recipe. Yeah. So when you upload a package to one private server, at least that binary is completely self-contained. You can download the recipe and the package from the same server. Good.
Yep, thank you.
Okay, and then this is what I'm going to show you. This is a new feature. We haven't even announced it. It's not documented yet. We have the blog post ready, but we didn't manage to publish so probably it will go next week. But I wanted to show you this new feature, okay? Because there is a use case that we were not addressing so far. Is okay, we have Conan Center and we have these 6,000 pull requests to Conan Center last year. That's amazing, but there are users that they want to use their own customizations, let's say to Conan Center recipes, and this is not that simple. Okay, these customizations, they cannot be merged in Conan Center. Okay, so they have to maintain their own fork of Conan Center recipes. So this is what this new feature is allowing to use a Git repo with recipes as a Conan remote, and this is what I'm planning to demo today. So the first thing that I'm going to do is I'm going to show you my current remotes. So if I list my remotes, I will show you they have Conan Center. In this case, Conan Center is disabled. Okay, I was not using Conan Center live in this demo. I was using my own Artifactory server, which is running locally here, and this one is the one that was enabled, and this one is the one that was used when I typed Conan install. This was the one working. Okay, so I'm going to do a clone of the github.com Conan Center index. So this is the repo that receives the 6,000 pull requests, and it's the repo that contains all the recipes from Conan Center. So our CI service is taking these recipes and it's building the binaries from these recipes. So what I'm doing here is I'm cloning the source. I'm cloning the recipes, the 1,500 plus recipes in Conan Center index. Let's wait a little bit until we get all of them. And okay, it's a little bit heavy repository with all that much history. I should have done a depth one, but okay, good enough. So what I'm going to do is Conan remote add. I'm going to name the new remote. I'm going to call it local, and I'm going to point it to the current folder. If I list my remotes, Conan remote list. Now I will see that I have the three repos. Okay, I have the Conan Center, the Artifactory that I'm using, and I have a new repo here that is a path and is of type local recipes index. This repo behaves exactly the same as my Artifactory server. It behaves exactly the same as as Conan Center, right? So I can perfectly list, for example, FMT from the local repo, and it will be listing the version that I have. And I can perfectly use these versions. Now, I will show you, I can go to my post estimation project. And I can perfectly, let's say, okay, let's add one more require. I'm going to add a require to FMT. I can add the find package here to FMT config required. I can add the linking to FMT. And I could go to the source code and I could be using here the include FMT format.h. Okay, so with this, I'm going to be clean. So these were the modifications that I did, basically adding the find package, adding the target link libraries, adding the requires to the Conan file, and then using the FMT library in my code. With this, I can do the Conan install, and it will get, of course, my dependencies that were already in the cache. Oh, sorry, I forgot about the compiler cppstd equals 17. And then I will realize that something is missing. Okay, it failed. If we check here, it's resolving FMT and say, hey, this is missing. Why the binary is missing? Because it's fetching the binary from my source, my recipes only repo. That means that recipe, that Git repo, doesn't contain the binaries. That means if I want to use FMT, then I should be building the binary from sources myself. But fortunately, Conan calculate build equal missing, and then Conan will be able to build FMT. Is building now FMT from source. And it will be just using it in my application. And that's basically it. It's using the find package, and everything is working. So this is what we had here is we managed to use a clone of the Conan Center Index repo, and we were able to consume packages directly from the repo without needing a server. Of course, for production, is typically we recommend using a binary server, which in this case Artifactory, because once you build your binaries, you want to put them in the binary server, so you don't have to build again from source again and again. So you cache them in your binary, and then your developers, when they are Conan installed, they will get the precompiled binary. But for the case that you maintain a fork of Conan Center Index with your customization, you can very easily build those binaries. You can very easily use your customization just by using a fork and using this new feature.
I have a question.
Yeah, go ahead.
So I used to work in the VC++ compiler backend, and I was the owner of LTCG. Are you aware of LTCG, link time code generation? That's whole program compilation. Which means that if you have a C++ application with 1,000 CPP files, the front end translates them into an intermediate language, and then it's the backend's job to optimize all of them together as a whole program and generate an optimized binary. Now, you just mentioned like a couple of seconds ago that it's better to have binaries cached in your server. This is one scenario where precompiled binary will not help. The compiler needs to be able to analyze all the source code at the same time. But maybe this is a corner scenario, not too important, not one of your targeted scenarios.
Yeah, no, this might be important depending on what you want. But also, at least what we learn from the users is many of them, for example, they will be using shared libraries. So their dependencies.
I'm sorry, what? I didn't hear that.
Many of them are they will be using, many of the users, for example, they will be
using file compilation. You're talking about one file at a time compilation, which is C++ to object code directly, file at a time. Yeah. I'm talking about, okay.
Yeah. So you mean, I think you are talking about link time
code generation.
That can be optimized.
Where the compiler needs to be able to see all the source at the same time.
Yeah. Of course, if you are managing like multiple dependencies and the dependencies are precompiled binaries, then this link time optimization might be challenging or impossible in many cases. But there are cases, like for example, your dependencies are shared libraries that you don't even, this is physically impossible. It's not depending on using a package manager. It's just your shared libraries are shared libraries, and you don't actually link at compile time with them. So that will be challenging, right? So it depends. It will be optimization, it will be bad for static libraries if you cannot enable the link time optimization. I think I'm not an expert in this sense. I've seen some users compiling the static libraries in some very specific ways, at least for some compilers, that they could kind of enable link time optimization when they were linking those static libraries and executables downstream. But I'm not an expert. I couldn't say how they managed. I know it was challenging. I know that they had to kind of juggle with their builds and do some crazy stuff, but they managed to do it with having like pre-compiled static libraries and then linking them. But in the general case, yeah, it might not be obvious. It might not be trivial.
No, but your previous example did, you answered the question which was in my mind. Is it just a binary package manager? But it seems to be no, it's source and binary. And you have binaries cached, which where if applicable, you can reuse the binaries. If not, you can download the source, your Conan downloads the source and builds them, right? Am I correct in that? It's both a source and a binary package manager.
It's
Am
both.
I right in that?
Yeah, it's both. So when I was using the FMT, for example, I didn't have the binary, so Conan downloaded the source and built the binary from source.
Okay. Yeah. That was kind of the question that was in my mind, but your example answered that. Yeah.
Okay, good.
It does both.
So I think we are. I mean, if the expected time was for 1 hour, I think I'm going to skip this one because I have other interesting things to explain. One of the good things about Conan 2 is that it has like new features for compliance. So yeah, I guess that all of you know about the X step thing that happened like a couple of weeks ago, right? So when this happened, GitHub removed or closed the repo. The GitHub repo for the X step sources was closed. So that means that even the non-vulnerable versions that was like less than 5.6, even the previous versions, you couldn't build them from source because the sources were temporarily disabled from the internet. Okay, so this is one of the good things that we were able to recover very fast from this because Conan contains a feature that is called the backup sources. So if you enable this, whenever Conan downloads something from the internet, it is able to store a copy in your own server as well, and you can later use that copy if the original from the internet is removed or is not available in a sense. Then Conan knows how to go to your own server and then fetch the sources from there. That makes your builds reproducible 10 years from now if you want to, no matter what happens to the internet, no matter to forge sources if they are removed or whatever, or even if someone tampers with the source and they remove something or they change something, no problem because you have a copy automatically in your server.
Yeah, that might be an issue because Microsoft owns GitHub.
I know.
Some things might vanish.
Actually, it was also like one of the reasons that we started this feature is that a few months ago, GitHub changed the checksum algorithm for all the zip files in their releases. And that was breaking half of the internet. Every package manager was basically complaining, and GitHub reverted. That I think GitHub at some point will actually change it again because it already announced that you shouldn't be relying on that checksum. So this kind of feature allow us, okay, if GitHub decides to change the checksum computation for the releases, it's fine. It won't break the whole Conan Center because we already have a copy with the old checksum, and we can of course gradually change the recipes to use the new checksum from the official source. But if they change it overnight, it will not break the whole Conan Center because we still have the copy. But I hope that you don't change it again because it will be painful for for the community in any case. Okay, another interesting feature that Conan 2 provides is the metadata. If you need, for example, there are many cases that users need to capture the build logs or the test results or the test executables, but they don't want to put them in the package because the package will be very heavy. And if every time you need to link with a library, you need to download all the logs, all the test executables and everything, is going to be heavy and costly. So the metadata allows you, for example, to automate the storage of all the build logs automatically with just a hook. It will apply to all recipes, everything that you are building from source. And when it is stored in the metadata files, it will store the metadata in the server, but it will not download them by default. They will be stored there, but every time that you are downloading things, it will download just the library, the headers and the static library or whatever to link with it, but it will not be, you will not be paying for the metadata files transfer, which can be pretty costly. So this can be very, very useful for many compliance reasons. Another new feature that is also hasn't been announced is the SBOMs. You know, SBOMs is single bill of materials, which is like a manifest. It's a manifest of what you have, of your dependencies. And these manifests can be very useful, for example, for security checking. So for some compliance, they will be, hey, if you are going to give me this application for getting the stamp, getting approval, I need you to give the SBOM of this application. So I'm going to demo this as well. And I'm going to demo two different aspects. First, if I type Conan help, I will see that I have my default, my built-in Conan commands, right? Which is Conan create, Conan install, Conan remote, and so on. Conan 2 is able to extend. It allows users to define their own commands, their own Conan commands, and it allows users to share those commands. For example, I'm going to Conan config install, and I'm going to install some custom commands that we have in a repo. Okay, so I'm going to install them from github.com, Conan.io, Conan extensions. Okay, and this is a repo that we have, and we put there some custom commands. Some of them also contributed by the community. And just by typing this, I'm expanding my Conan application to have more commands. So you can see here that besides my built-in commands, I have other commands as well here. We will have a look to the last one. The last one is SBOM Cyclone DX. Cyclone DX is a standard for SBOMs. Okay, so this was contributed by a user, and it allows to do Conan SBOM Cyclone DX. Let's see what it says. Okay, it requires a path. I'm going to provide a path. Okay, now it's complaining that it requires a format, and I'm going to specify the format 1.4 XML format. And I'm going to dump it to a SBOM XML file, for example. Now, we can see that we have the Cyclone. This is a Cyclone standard SBOM containing all the information of the dependencies that we were using here, including the build tools, like Mason, for example. Ninja is here because it was also a dependency. And here we should start to see the different libraries, like Broadly and bzip2, and we will have a full file, a full SBOM specifying all my dependencies, which is what is necessary for typical compliance. So I saw here actually two things: how Conan can be extended with custom commands, and one of these commands that allows you to compute a SBOM, which is very interesting. Okay, and to finalize my talk today, I'm going to talk about the CPS. CPS is a very, very exciting initiative. Some people, Robert and Agustin, are aware of it. They are also participating in these meetings and this initiative. is about bringing a common package specification. It's a language, it's a definition of a package that build systems can understand. So we are talking in this case of a compiled binary. Let's say that we have a setlib as a compiled binary. It doesn't matter how it was built. All it matters is that we have some headers and we have some library, and we have we want to have a description language that is understood by every build system there. This is what we call the CPS. The CPS, it has had other previous work, like in the ISO C++ or libman, and the main CPS repo that I will be sharing later. The CPS is not the first attempt to address this issue. Okay, actually, the package config PC5 is an attempt, is an implementation of this concept. Hey, we want a language to define dependencies, information for the consumers. And the CMake config, CMake files is also another approach for this problem. Both of them have limitations, have well-known limitations, and the reason that we are trying to collaborate in this CPS specification is that we think that a better solution, a more general and more powerful solution is possible. Conan also has its own implementation. Conan recipes, in its package info method, it contains the definition of what is inside a Conan package. And this definition is what allows Conan packages to be used by any build system, CMake, MS-Build, Meson, whatever. So the whole idea of the CPS is that it is bidirectional. So build systems are able to generate, when they are building something, they are able to create a CPS file, and this CPS file is able to be understood by other build systems. A CPS file would be something like, it could be conceptually very simple. For the setlib library, it could be something like this, something that specifies your headers are in this folder, your libraries are in this other folder, and the library names, this is the name of the library. Okay, a very simple example. So we say, okay, not so fast. It's not that simple. If we start to analyze, if we start to discuss, for example, about the included directories, hey, is this going to be a minus I or is a minus I system? Or it should be an absolute path or it should be a relative path. We can add a convention that by default, if you don't specify anything, it's going to be include, or you need to specify include even if it's the kind of the default. So there are many aspects there that needs to be clarified and standardized in the CPS. Also, things are not that simple as setlib. Okay, if we go, for example, for OpenSSL, which is a very popular library, we will see that actually in OpenSSL there are two libraries. You build OpenSSL and you get libSSL and libcrypto. And libSSL depends on libcrypto. So when someone is, hey, I'm linking OpenSSL, what does that mean? They want to link both libraries or no? Actually, there are users that sometimes they only want to link with libcrypto without linking with libSSL. So that means that when you have a package, that package might contain more than one library. And the CPS specification need to represent also this. At the moment, this is called components. And components might specify you have the SSL component, which represents the libSSL library, and you have the crypto component that contains the libcrypto library. And these components also introduce the problem of the representation of dependencies. Okay, and in this case, there are internal dependencies. The SSL component depends on the crypto component, and in turn, the crypto component depends on the setlib, which would be external. It will be another CPS file that should be located somewhere in the system. So I wanted to finalize today's talk with a quick overview of what is happening. So we are having these meetings. CMake already implemented like a proof of concept that it implements a load package method there that you can pass a CPS file, and it will be reading the CPS file. It will be equivalent of doing a find package. But instead of doing a find package, is using the CPS specification. And to finalize the talk, then I wanted to show you, let's say if I'm able to do this. Okay, so I've changed to a branch that we are containing some ongoing work here. And if I type Conan install, I'm going to type a new generator, which is called the CPS generator. And if everything goes well, it should be able to generate CPS files of all my dependencies for me. So if I check what has been generated here, I will see that I have the CPS files, okay, that Conan has been generated of the dependencies. In this case, Upsale, for example, contains a bunch of components, so we can see the specification of the different components of Upsales will be here. In theory, we haven't got there yet, but in theory, you should be able to pass these CPS files to CMake or other build system, and it will be automatically using them. It will be like a smarter and more integrated approach than Fine Package. So this is the kind of thing that we are working on at the moment in the CPS. I'm excited. I think it will be challenging, but I'm optimistic that we can get to something that will improve the whole ecosystem of around C++ build systems and package managers, and it will allow us to cooperate even more and work better together. So these are some of the links. If you are curious, I encourage you to go to these repos. I think specifically the CPS repo is very interesting, and there is also a mailing list. There is a channel in the CPB Lang Slack. So there are different ways to join this initiative if you haven't yet. Okay, so to finalize my talk, just some summary. I've presented to you the new transparent integrations with CMake that allows you to use Conan without having to modify a single line of your CMake list, which I think is very important, both with a Conan install and with a CMake provider, so you don't have to type Conan install. I've also introduced a new feature, the local recipes index feature, that allows you to work with a fork of Conan Center index and to use it as a remote, very conveniently for customizing and maintaining your own fork of Conan Center index. I presented as well a few new tools for compliance, like the backup sources, the metadata, the custom extension commands with the SBOM. This is only like the tip of the iceberg. As I said, there is a bunch more of things, like log files, for example, and other things that will allow you to have better builds, more reproducible builds, and these kind of things. And I've also given a few hints about what we are working, specifically what we're working in the community, in the standardization process, trying to come up with a better standard that will make us able to collaborate better. So thanks very much. These are some of the links that if you are curious about the things that I've been explaining today, you can check them. And that's it. If you have any question.
I have a question. Thank you. I have a question. So
yeah,
can you hear me?
Yeah, I can hear you.
Okay. So it seems like this CPS you are talking about is a meta language of some kind, which is kind of one level above Make or CMake specification. Am I right?
It's not one level above or before or below, above or below.
It's the same level as. Then what problem does it solve that those other?
It's an interface. I think it's an interface between build systems and tools like package manager. So it will be, you have on one side, you have, for example, Meson build system. Okay, Meson build system will be building something and creating a CPS file. And you have here Visual Studio or CMake that will be reading this CPS file to be able to use the library that the other build system created. Okay, so it's an interface. It's an interface between tools, but I would say at the same level as the tools.
Are you aware of a comment? It seems many people have tried to solve this problem over the years, many different tools. Are you aware of Microsoft's build command? MS build. It has its own syntax, MS build. Microsoft build. Of course.
Yeah.
How does CPS compare with that? Is it better, worse? Is it more powerful, less powerful? What would you call?
I think there are people in the room that may be able to respond better than me. But the idea.
I never bothered to learn the syntax of MS Build. Somebody else had to.
Yeah, I can tell you. I can tell you what we are doing today in Conan, because we have the same problem. We are integrating natively with MS Build. So the way.
Wait a second. What does that mean? Does that mean MS Build called you, or you call MS Build?
No, is MS Build is able to use files that are generated. So when you type Conan install, Conan can generate for you properties files, .props files.
Okay. That
Then
MS Build uses.
Exactly. You load those files into your Visual Studio solution, and then Visual Studio would be able to use your dependencies that you install with Conan install. Okay. So what we have here is a translation process. We translate from the Conan information to a MS Build properties file.
So
right?
if I may interrupt. What are the different tools that Conan is compatible with? I mean, from what I can see, it does make, CMake, MS Build. What else?
Yeah, Meson, Bazel.
What is that?
Meson.
Okay.
Meson or Meson. I don't know how do you pronounce it. I tend to call it Meson or Meson, but it's
I'm not familiar, but never mind. Okay.
The Meson build system is becoming very popular in Linux, specifically in the GNOME environment. So I think like GTK and many of those libraries in Linux that started with the G, they're built nowadays with Meson. And some of these like Systemd, I think Systemd probably switched to Meson as well. I think someone is raising the hand there, so probably someone can give better in there. So Meson is becoming very popular in some Linux.
And there's CMake as well, right? CMake for Qt stuff.
Yeah,
I mean, there are so many.
Yeah. There are many. So we have some like draft or preliminary for CMake, for QBS, for Premake, but honestly, they are very, very little used. So they will be like not ready for production. They will probably fail because they don't have enough users to be as robust as the other. So I would say the main one will be MS Build, CMake, Meson, and AutoTools in this order. And then we have Bazel then, and yeah, that will be basically the most mature ones.
Are any teams in Microsoft using Conan? That is proprietary information. You cannot tell me.
I know it, but I cannot tell.
Yeah. Okay.
Yeah, I think Robert is raising the hand.
Yeah.
In the back.
Yeah, I don't know if the camera is cutting me off or not. It looks like it's not on this side, but I don't know if you can see anything.
I only see your hand like this.
Yeah. Okay. All right. Good. I'm glad I moved then. Is the Conan is the Cyclone DX SBOM extension officially supported by JFrog, or is it community maintained?
No, it was contributed by a user. So we have this repo that is called Conan extensions. Mm-hmm. That is intended for this purpose, to be able, users can contribute this kind of functionality that is not well suited for being built in Conan for different reasons, because it's proprietary, for example, or it's not as mature or as tested, or it brings too many dependencies or whatever. That is, so we are targeting them to the Conan extensions repo, and then in this Cyclone. This Cyclone custom command was contributed by a user. So it's not even us. Yeah, it's in our repo because we try to have centralizing the user contributions for awareness. But you can also put it in your own custom repo, proprietary, private one, and then use your commands from there.
So does that mean that if I went and I used this extension and I had a bug, then you would direct me to the user who contributed it, and it's up to that user to support me, or is it officially supported by JFrog?
It's like, I mean, officially, the repo is in the organization. So that means that we is part, and it contains the license, and it contains the CLA and everything. The truth is that we don't have the resources to support it. It's not a first class as it is what's built in. Okay, so we try, it's a best effort, we try to support it, but it might take more time to attend the bugs or things like that. It depends, as always, it depends on the demand. So if there are many users interested in this functionality, it will be prioritized, and if not, it will be like deprioritized. Typically, it's something that is not as critical, because the idea with custom commands is that it's very easy. You fork the repo, and you can customize very easily your command. So it's not the same as a built-in functionality.
Thank you.
Yep.
So the binaries that we download, where do they come from? Are they built by JFrog, or is it they're built by JFrog unless we build them ourselves with different flags, and then the ones we build with different flags get uploaded for us to download later? How does that happen?
So the binaries that we were using today, you mean?
So let's say I want a package. I want the zlib package. So I do a Conan install of the zlib package, and I get a binary for that zlib package. How did that binary get built? Is it something I build and upload and re-download later? Or is it something you build or something one of your customers builds?
It's whatever you want. So you have full control over that, right? So if you just install Conan from scratch and do not configure anything, and you type Conan install safely, the Conan Center remote is configured by default. So it will be checking Conan Center. It will be, the first step is to fetch the recipe of setlib, and then it will check your configuration. So, okay, you are using Visual Studio 22, whatever. Do I have a binary in the server for your configuration? Yes. And if the answer is yes, it will try to download the binary to your cache and then use the binary. But you have full control over that. If you want to force the build from source, you type does build equal star, and it will not download the binaries. It will force the building from source in your local cache. Or you can, as with the local recipes index, or just by copy, you can copy the recipes or do a Conan create of the package from source, from the recipe, and then Conan upload to your own private server. And then when you type Conan install, it will be fetching the binary from your server, which is actually, it's a very recommended flow. Honestly, C++ and native binaries is not something, I don't believe in a central repository containing the binaries for production. For users, there are so many compliance rules, restrictions, and everything. Most of our users don't use binary from Conan Center. They build their own binaries. I think it's very important, and this is a flow that is first class in Conan. Building your own binaries and storing and reusing your own binaries in your own server is very, very optimized. I mean, Conan is trying to do this flow very, very efficiently. So it's not that Conan will force you to use binaries from Conan Center if you don't want to. Actually, the opposite. It will encourage you to use your own binaries if you want to. Okay, that answers my question. Thank you very much.
There's somebody who has his hand raised for a while.
Hey, Diego, I think an aspect of what Peter may have been hinting towards is that some people might be worried about their bits that they build locally that might be proprietary leaking back up onto your server. You never steal any of their binaries that a user builds. Anything that's binary on your server, you've built, correct?
Exactly. So if I understood correctly, it's the pipeline. So users that contributors that contribute to Conan Center only contribute GitHub pull request with source code of the recipes. They never contribute a binary. So all the binaries that are in Conan Center, we build them. They were built in JFrog CI, and actually we have a bunch of care and security measures. So every pull request is manually reviewed. So we don't merge anything without our review, right? And we have a bunch of automated checks and things like that to make sure that nothing bad happens, or to be as sure as possible that nothing. I mean, with the XState thing, it's impossible to be 100% sure. So they will eventually find a way, but at least we try as much as we can to have a secure environment. And this is one of the reasons that we are very happy that most of our users, they are not using binaries from Conan Center. We don't try to convince them that they should be doing that, because we think it's more secure, it's safer if they build their own binaries. So we tell them, hey, just take Conan Center index repo, the source repo, which is the recipes, which is the knowledge. It's like VC package. The most of the value is in the knowledge that is contained in the recipes or in the ports, how to build the things. Because the thing is that the open source ecosystem is wild. Building things from scratch is terribly complex. And Robert knows it's a nightmare. So the knowledge that is in the recipe is the real value. Just building the binaries from the recipe is common is CI. Just throw machine at it, build your binaries. It's not the real value of that. Being able to catch the binaries, it's important. But trying to force everyone or trying to convince to use binaries from Conan Center, no, we don't want that.
It's not just a question of privacy. I mean, secrecy of the bits that users might upload. Is that malicious code binaries might be uploaded, and you might not have a way to catch that. So that's a big security issue. So you have to generate the binaries, and at least then users might have some confidence that that is not malicious code injected into the binary.
Absolutely. So no single binary byte comes to Conan Center. So we build everything from source in Conan. There's no way that a user can contribute a binary that was not built in Conan Center.
Okay, any other questions? We got 9 minutes left before we have to get out of the room.
You demonstrated automatic source backups, I think is what you called it, right?
Yep.
What was the term you used for that?
Backup sources.
Backup sources. Is backup sources automatically does it come in the box with Artifactory when you set it up to serve as a Conan remote?
No, you need to configure what is called a generic repo. Actually, any HTTP server that provides a basic get put functionality of files should be enough. In this case, we are implementing it with a generic repo. So the way that it works is when you have an Artifactory server, in this case, you have a Conan repo containing the Conan packages. And then if you want to have the backup sources, then you create a generic repo. In the Conan configuration, you have this configuration that you need to put the URL of the generic repo, of the HTTP repo that can contains the, basically files. Blocks.
Sorry, you said the word repo a few times. Is that a Git repo, or is it does repo mean something more generic in Artifactory?
Yeah. So sorry about that. So the naming in Artifactory is repos for binary repos. So when I'm talking about an Artifactory Conan repo, it's an Artifactory binary. It contains Conan binary packages, and the Artifactory generic repo is a file server. It is typically used to contain binaries, binary blocks. So these both generic and Conan repos in Artifactory, those are artifact repos. No, they are not intended to be source repos. They are not intended to be Git repos.
Yeah, that clears things up. Thank you.
Have you ever given any thought to government restrictions? Like, let's say, typically crypto packages like PGP have been restricted, or some other packages. Does your default repository do they so? Are they allowed? Do you do that, or do you follow US government?
We are not. You are talking about package signing, right?
Not signing. I'm talking about actual packages which are restricted as, for example, PGP was at one time considered munitions by the US government. Classified cryptography, secret code, which is not allowed to be hosted in the US. So do you do anything like that? Do you have a policy on that?
I can maybe answer that question. So I used to work at a defense company that used Conan. And for that issue, so we work with classified information. So for that issue, we would have our own little Conan, like binary private.
Private repository, not the public. Oh,
Yeah, we wouldn't use Conan Center. Yeah.
not the standard.
Yeah, so our policy is not doing anything illegal.
Illegal, okay.
So if someone point us, hey, you have something that you shouldn't have in your Conan Center repo, we would take it down, of course.
You have people looking at that saying, okay, how about if I make a copy of the PGP sources and rename it to something else and try to, is there somebody actually looking at it? And I'm just kidding.
People keep an eye. So when the exited vulnerability went public, we were notified. If hey, there are exited packages in Conan Center, and people will be letting us know very, very quickly.
Yes, I suppose the NSA will come knocking on your door.
Yeah, and there is also there are some bots out there. So, for example, there are automated services and security and things that they are scanning Conan Center. So they actually keep an eye. So if something is wrong there, we will probably know by the users and the community. They will be reporting us something.
What agents do you work for, or is that classified?
It's like the US Navy. I used to work for.
Okay, so folks, we got about 5 minutes left, so we should probably wrap up and start heading for the door so that folks can go home. Let me go tell them to stop the video real quick.
Thanks, Diego.
The recording,
Thanks.
the recording was.
Thanks very much to you for being
The
here.
thing I did.
It's a pleasure.
Hey, Diego, you were talking about last week when the XZ.
Do you have any
did
insights
happen?
on Google's hardware across the year?
Or is there too much crosstalk to hear me there? Or?
No, sorry, Chris. Maybe
I heard
the
about it.
conference room can mute them.
I was wondering, you were talking about that you guys have a backup of that
Do you,
when it wasn't working or when the sources got shut
We
down.
have a package.
Were you propagating the leak after a while it was still happening?